What if I told you that everything you think you know about space is wrong? Not because the facts are incorrect, but because our human brains are fundamentally incapable of grasping what these distances actually mean. We throw around numbers like 4.4 light-years or 93 billion light-years as if saying them out loud somehow makes them comprehensible. But here's the uncomfortable truth. We're not really understanding them. We're just repeating numbers that have lost all meaning. Today, I'm going to show you the critical mistakes we make when trying to comprehend the scale of the universe, and why even the most educated astronomers struggle with this same problem. Let's start with the first and most dangerous mistake, the mistake of familiar comparisons. When we try to understand cosmic distances, we instinctively reach for comparisons we can visualize. We say things like, if you drove to the moon at 100 kilometers per hour, it would take you over 160 days. This sounds helpful, but here's the problem. Your brain doesn't actually know what 160 days of continuous driving feels like. You've never done it. No one has. So we're using an incomprehensible experience to explain another incomprehensible distance. We're stacking one abstraction on top of another and somehow expecting clarity to emerge from the confusion. Consider the distance to the Sun, 150 million kilometers away. Someone helpfully adds that if you flew there in a commercial jet, it would take 19 years. But can you really picture 19 years of continuous flight? These comparisons don't illuminate understanding. They simply transfer our confusion from one incomprehensible scale to another. We're translating a language we don't understand into another language we also don't understand. This brings us to the second critical mistake, the failure of incremental scaling. We have this notion that if we just build up distances gradually, starting from something familiar and slowly expanding outward, eventually the cosmic scale will click into place. We start with Earth, then the Moon, then the Sun, then Mars, methodically working our way through the solar system. But this is fundamentally wrong. The scale of the universe doesn't work incrementally. Each jump represents not just a larger distance, but an entirely different category of distance that renders all previous distances meaningless. Think about this. The Moon is 384,000 kilometers away. The Sun is 150 million kilometers, roughly 400 times farther. But when Neptune is 4.5 billion kilometers away, the Moon distance becomes a rounding error. And when Alpha Centauri is over 40 trillion kilometers away, even Neptune's distance is utterly insignificant. We're not climbing a ladder where each rung builds on the last. We're leaping between entirely different ladders, and each new ladder makes the previous one vanish from relevance. The third mistake is the misuse of astronomical units themselves. When astronomers tell us Alpha Centauri is 276,000 astronomical units away, they think they're being helpful. But we cannot picture 276,000 iterations of a distance we couldn't comprehend in the first place. This is why astronomers switch to light years, but that's not simple either. Light travels at 300,000 kilometers per second, already incomprehensible. Multiply that by 31 million seconds in a year, and you get about 9.5 trillion kilometers. We've taken something we can't comprehend, multiplied it by something else we can't comprehend, and somehow expected to arrive at comprehension. We've just given it a prettier name. The fourth critical mistake is what I call the illusion of visualization. We watch computer animations that zoom out from Earth, through the solar system, past the stars, through the galaxy, until we see the entire observable universe. These visualizations are magnificent, but they're fundamentally deceptive. They compress billions of light years into seconds of screen time, making everything appear smooth and continuous. They make the universe look like a place you could navigate. But here's what these visualizations don't show you: the crushing emptiness of space. When we see an animation of the Milky Way with its beautiful spiral arms filled with stars, we're seeing 400 billion stars compressed into a glowing disk. It looks crowded, but the reality is that the average distance between stars in our galaxy is about 5 light years. The nearest other star would be so far away that even traveling at the speed of light, it would take you 5 years to reach it. The visualizations make the universe look accessible. The reality is that it's almost perfectly designed to be inaccessible. This brings us to perhaps the most profound mistake: the assumption that understanding cosmic scale is merely an intellectual exercise. We treat these distances as interesting facts to memorize. But the scale of the universe isn't just a fact. It's a context that should fundamentally alter how we understand ourselves. When we learn that the entire reach of human radio broadcasts extends only about 100 light years from Earth, we should pause and absorb what that means. Our galaxy is 100,000 light years across, so our radio bubble represents 0.1% of our galaxy's diameter. To the vast majority of our own galaxy, humanity doesn't exist. We haven't been detected because our signals haven't reached there yet, and they won't for tens of thousands of years. Consider the famous pale blue dot photograph taken by Voyager 1 in 1990. The spacecraft was 6 billion kilometers from Earth when it turned its camera back toward home. In that image, Earth appears as a tiny speck, barely visible. Carl Sagan reflected on this image with profound words about everyone you love, everyone you know, every human being who ever lived, living out their lives on that mote of dust suspended in a sunbeam. But here's the mistake we make with even this profound reflection. We hear these words, we feel moved for a moment, and then we continue with our lives exactly as before. We don't change. Our brains acknowledge the information intellectually while simultaneously insulating our emotions and behaviors from its implications. It's a psychological immune response, protecting us from existential vertigo. Now, the sixth mistake is nihilistic resignation. When people realize their inability to truly comprehend cosmic scale, there's often a slide into cosmic nihilism, the notion that if we're so small and insignificant, then nothing matters. Or there's dismissive indifference, deciding that if they can't understand it anyway, there's no point in thinking about it. Both responses miss something crucial. The fact that we cannot fully comprehend cosmic scale doesn't mean that attempting to comprehend it has no value. The attempt itself, the struggle to expand our perspective beyond our natural limitations, this is where the value lies. Let me give you a different way to think about this. Instead of trying to comprehend the distances themselves, try to comprehend the implications for connection and communication. Imagine you could send a message to a civilization 20,000 light years away. Your message travels at the speed of light. 20,000 years later, it arrives. If they immediately respond, their message takes another 20,000 years to reach you. The minimum time for a simple exchange is 40,000 years. 40,000 years ago, humans were still in the Stone Age. This means that communication with distant civilizations isn't really communication in any meaningful sense. It's more like leaving messages in bottles, knowing that by the time anyone finds them, the world that created them will have long since vanished. The seventh mistake is treating Earth as just another location in the universe, as if it's simply one address among countless others. But Earth isn't just another location. It's the only location where we know for certain that the universe has become aware of itself. On this small planet, matter has organized itself into patterns complex enough to look out at the cosmos and ask questions about its own existence. The universe, through us, is examining itself. As far as we know, this tiny blue dot might be the only place in the entire observable universe where consciousness exists. We're not insignificant because we're small. We're significant precisely because, despite being so small, we can nevertheless comprehend, at least partially, the vast arena in which we exist. This leads us to the eighth and final mistake, the mistake of separation. We think of ourselves as separate from the universe, as observers looking at something external. But this division is completely false. The atoms in your body were forged in the hearts of stars billions of years ago. When those stars exploded, they scattered those atoms across space. Eventually, they became part of Earth, and then part of you. You are literally made of stardust. The iron in your blood, the calcium in your bones, the oxygen you're breathing, all of it was created in stellar furnaces. You are the universe, locally organized into a pattern that can think and feel and wonder. When we look up at the night sky and feel small, we're experiencing only half the truth. Yes, we are small compared to the cosmos, but we are also the cosmos, concentrated and aware. Every thought you have is the universe experiencing itself from a particular vantage point. You're not looking at the universe, you're looking at yourself from the inside. So what do we do with all of this? The answer isn't to achieve perfect understanding. The answer is to hold these tensions without resolving them. We embrace our smallness without letting it diminish us. We acknowledge our isolation without letting it lead to despair. The universe is vast beyond human comprehension. The distances are crushing, the timescales are overwhelming, and our place in it all is almost too small to measure. But on this tiny world, something extraordinary is happening. The universe is waking up, looking around, and asking questions. We matter not because we're big, but because we're aware. We matter not because we can travel the cosmos, but because we can contemplate it. We are the universe's way of understanding that it exists. And in a reality as vast and ancient and strange as ours, that might be the most important role anything could possibly play.